Welcome back to Module 2, Physics. In this video, we cover rotational motion, including angular velocity and acceleration, and periodic motion, such as a swinging pendulum. Angular velocity describes how fast something rotates, measured as the angle turned in radians, divided by the time taken. It is given the symbol omega and measured in radians per second. For example, turning through 6 radians in 2 seconds gives an angular velocity of 3 radians per second. Every point on a spinning object shares the same angular velocity, but their linear speed depends on how far they are from the center. Linear speed equals angular velocity multiplied by radius. Since both points here rotate with the same omega, the outer point, with the larger radius, moves through a greater distance each second, so it has a higher linear speed. Angular acceleration is the rate of change of angular velocity. Alpha equals the change in omega divided by time. In the diagram, each snapshot sweeps a bigger angle than the last in the same 1-second gap, showing the rotation is speeding up. This applies directly to spinning components like turbine rotors during spool-up. Periodic motion is any motion that repeats itself at regular time intervals, such as a swinging pendulum or a rotating propeller. The period, t, is the time taken to complete one full cycle. For a pendulum, that means swinging all the way from A through the center to B and all the way back to A again. Frequency is how many complete cycles happen per second, measured in hertz, and it is the reciprocal of the period. mf equals 1/t. A short period means the cycle repeats quickly, giving a high frequency. This relationship is used to convert an engine's rotational speed in RPM into a frequency in hertz for vibration analysis. Pause the video and try this problem yourself. Linear speed equals angular velocity times radius. 5 radians per second times 0.4 meters gives a linear speed of 2 meters per second. Question 1. What is angular velocity? The answer is b theta over t. Question 2. A point is 0.5 meters from the center of a disk spinning at 4 radians per second. What is its linear velocity? The answer is A, 2 meters per second. Question 3. What is the relationship between frequency and period? The answer is Bf equals 1/t. Here is your quick reference. Angular velocity is theta over t. Linear speed equals angular velocity times radius. Angular acceleration is the change in angular velocity over time. The period is the time for one full cycle, and frequency is 1 divided by the period. That covers angular velocity, linear versus angular speed, angular acceleration, and periodic motion. In the next video, we look at vibration, harmonics, and resonance. See you there.